Hey guys, we are looking at an equation and we are being asked to graph the parabola that goes along with this equation, okay? Now, we are currently in vertex form. If you're looking at yours and you're like, I'm not in vertex form, I will link a video for you in the corner, okay? But we are in vertex form. Cool thing about graphing parabolas is we have what we like to call a parent graph, okay? So if you were just being asked to graph y equals x squared, this is what your graph would look like, okay? But you're like, that's not what I'm being asked to graph. That would be nice. I'm being asked to graph this guy, okay? I've got a -1/2 out front, a +1, and a +6, okay? This is where the good news is about being in vertex form, because vertex form tells you how this graph is related to the other one. You just change it a little bit, okay? So, where's my other paper? Here it is. Okay. So if you don't like words, sorry, just listen to the words. Don't read them. Okay. If you like to read them, read them. So this number, if we have one out front, tells us a couple things. If it's positive, my parabola is going to open up like a smiley face. If it's negative, my parabola is going to open down like a frowny face. Okay. If there is a number out front, like a 2, 3, 4, 5, whatever, it is going to stretch my graph. If there is a fraction, it's going to compress it. Now you're like, I don't know what that means. Guess what? I'm going to show you. So that blue graph is that parent graph I showed you earlier. Okay, the green has the 4 out front, and you can see how it's stretched, right? It's like skinnier. The red one has the fraction out front, and you can see how it's compressed, right? They're all still parabolas, but they're just different types of parabolas, you could say, right? So in this case, we have that -1/2 out front. So that tells me that my parabola is going to open down. And also there's going to be some sort of a compression, okay, that we will show when we plug in some points, okay? All right, this number here tells me how much my parent graph is shifted to the right or left, okay? Now, you actually do opposite of the sign. So when you see that +1, you might think, oh, to the right one. But we actually do opposite of the sign. So I'm going to go to the left one with that one, okay? Then this number being added or subtracted on the back tells me how far my graph is going to shift up or down. And with this one, you stick with the sign. So that +6 means I'm going to shift it up 6, okay? All right, so let's see what this is going to look like. Guys, my kids are playing video games upstairs, so if you hear them jumping, that's what that noise is. Okay, so on my parent graph, my vertex is at 0, 0, okay? But we figured out with our equation that this one is going to be shifted to the left 1 and up 1, 2, 3, 4, 5, 6, okay? So this is my new vertex, okay? And then we know that it's going to open down, right? Like a frowny face, and that there's going to be some sort of compression that makes it wider than my parent graph is, okay? So just a quick note, some teachers might be okay with you just graphing the vertex, showing that you know it opens down, and then just writing a note that says like, there is a compression of 1/2, okay? I had some teachers that that's all they wanted me to show I knew, okay? But we also can plug in points so we can see a little bit better what it might look like, okay? So let's go ahead and see. There's a couple things we could do. I kind of want to know, since I know this is opening down, I kind of want to know where it crosses the x-axis, okay? So to know where it crosses the x-axis, I'm going to plug in 0 for y, right? That'll tell me where it crosses the x-axis. So I'm going to plug in 0 for y, and I get 0 equals -1/2 times x plus 1 squared plus 6, okay? Now, a cool thing to note, this is something I love about math, and I know I'm a weird internet math lady, but if you look at this and think about it, with this opening down, it's going to cross my x-axis in 2 places, right? So from this one problem, this one number I'm plugging in, I should get 2 answers. Let's see what happens, okay? So my goal here is to get x alone. So first I'm going to subtract that 6 from both sides, okay? So I'm going to have negative 6 equals negative 1/2 times x plus 1 squared, okay? Now I want to get rid of that negative 1/2, right? To get rid of that, I'm going to multiply both sides by a negative 2, okay? So when I multiply this side, it's kind of hard to show with there's already being parentheses there. But when I multiply this side by negative 2, negative times a negative becomes a positive, right? And then 1/2 times 2 gives me 2 over 2, which is just 1. So these go away, right? So on that side, I'm just left with the x plus 1 squared, okay? But if I multiply this side, I got to multiply the other side. So I'm multiplying the other side by that negative 2. Negative 2 times negative 6 gives me 12, okay? So I've got 12 equals x plus 1 squared, okay? Now, to get rid of a squared, I take the square root, right? So I take a square root of both sides. That gets rid of those squares, right? Okay, this is where it gets cool. Are you excited? Okay, whenever we introduce square roots, we need a plus or minus sign, right? Because it's kind of hard with 12. But if you think of the square root of 9, okay, the square root of 9 is asking what 2 numbers multiplied together give me 9. And 3 times 3 gives you 9. And negative 3 times negative 3 also gives you 9. There's 2 possible answers. So same applies here. So when we introduce a square root, what I'm going to do is I'm going to write plus or minus the square root of 12 equals x plus 1. Okay, all right, you're like, this is looking a little scary. I didn't sign up for this. Don't worry, okay? We're doing this on a graph, so we're just trying to get an approximate point. It doesn't have to be perfect, okay? So I actually am going to plug this into my calculator and get a decimal for what the square root of 12 is, okay? An approximate. It doesn't have to be perfect because we're just trying to get an idea of what our graph looks like, okay? So when I plug in the square root of 12 to my calculator, I get 464, and it keeps going. So I'm just gonna leave it at 3.46, round it, okay? And we're saying that is equal to x plus 1, okay? Now, this is where I'm going to split into 2 answers, okay? So I'm going to have the positive over here, the 3.46 equals x plus 1, and the negative 3.46 equals x plus 1. Now, there are some problems where you would just want to leave it as a square root for an exact answer. But again, since we're graphing, we're just trying to get a general idea of what this looks like, okay? So I want to get x alone. I'm going to subtract 1 from both sides. So I get 2.46 approximately equals x, okay? And then when I subtract it from this side, I get negative 4.46 approximately equals x. Okay, so those are my points. So I get negative 4.46 when I plugged in 0 for y, and I also got 2.46 when I plugged in 0 for y. Okay, guys, we got 2 answers. Didn't I tell you we'd need 2 answers? Isn't that cool? Okay, so I'm going to do negative 4, and then 0.46 is just a little less than half, and so I'm going to put it about there, okay? And then 2.46 approximately there. You see why we didn't need to have them be exact? All right, then we're going to draw our parabola. Remember, it's not a straight line. It's going to be a curved line, a little something like that. Oh gosh, guys, that was not the best line I've ever drawn, or curve, whatever I've ever drawn. Okay, if you did want to plug in a 0 for x to figure out where it crosses the y-axis, that would be awesome. Pretend like that's a pretty line or curve, okay? All right, hope this made sense. If you need some more videos, I will link a playlist for you. Thanks, bye.